What do water pistols, cranes, and car brakes have in common? They all have hydraulics to thank, which is the movement of liquids. In this video, we'll look at how hydraulics multiply forces. You should already know about pressure in gases and liquids, which we looked at in these videos. Solids, liquids, and gases. Which of these can be compressed? Well, gases definitely can. Think of compressing a balloon. And solids definitely can't. Think of compressing a tree. But liquids, it requires a great deal of pressure to accomplish a little compression. For that reason, liquids are sometimes referred to as being incompressible. We can use liquids to transmit pressure out equally in all directions. Technology using moving liquids is known as hydraulics, which is where the water pistol, cranes, and car brakes come into play. They all use hydraulics. Hydraulic systems consist of two pistons, a master piston, where pressure is applied, and a slave piston, which the pressure is transmitted to. Let's look at an example of how system multiplies pressure. Remember, pressure is calculated using this equation. A force of 20 newtons is applied to the master piston, which has an area of 0.001 meters squared. The slave piston has a surface area of 0.1 meters squared. What force is produced by the slave piston? First, we need to calculate the pressure produced by the master piston. So, 20 newtons divided by 0.001 meters squared to give 20,000 pascals. Now we can calculate the force produced by the slave piston. So 20,000 times 0.1 meters squared to give 2,000 newtons. So the force on the master piston was 20 newtons, but the force applied to the slave piston was 2,000 newtons. The force has been multiplied. Small force on a small area has resulted in a much larger force on the slave piston. It's the same principle that is used in hydraulics. A small input force has resulted in a large upward force. Exactly this, but on a much larger scale, is used to generate forces strong enough to lift things, like hydraulic jacks. Now it's your turn to try an example. A force of 2,500 newtons is applied to a master piston with a surface area of 0.1 meters squared. Calculate the force generated in the slave piston with a surface area of 0.5 meters squared. Pause the video and work it out. So the pressure produced by the master piston is 25,000 pascals. And so the force produced by the slave piston is 25,000 times 0.5 meters squared, giving 12,500 newtons. That's a massive increase in force from the original 2,500 newtons applied to the master piston to the 12,500 newtons produced by the slave piston. The science of hydraulics is due to Pascal's principle. Because liquids can't be compressed, the pressure stays constant between the master and slave piston. And thanks to the relationship between pressure, force, and area, it means a relatively small force can be applied to the master, which will result in a much larger force on the slave. Thanks to hydraulics, we can apply a small force to our car brakes, but a large force is then exerted on the brake pads, thus bringing the car to a stop. Or the driver of a digger truck can pull a handle with a little force, which then, thanks to fluid pumping through narrow cables and pipes, results in hydraulic arms extending out with much greater force. Now that you know about hydraulics, when you're out and about, have a look around at different machines, and you'll be surprised at how many machines use the pressure of fluids to work.